Section 3.4, Objective. I can apply theorems about measures of angles related to triangles. So first of all, the definition of a triangle. A triangle is a figure formed by three segments joining three non-collinear points. Okay, so if I have point A, B, and C, so those are three non-collinear points, and if I make segments, then that forms a triangle. Okay, and so with the triangle we talk about different parts. The vertices, are the points that create the triangle. So in this case, the vertices would be point A, point B, and point C. The sides are the segments that create the triangle. So we would talk about segment AB is a side of the triangle. Segment AC is a side of the triangle. And segment BC is a side of a triangle. And we would also talk about the angles of the triangle, which would be angle A, angle B, and angle C. Okay. And then we can classify triangles, or one of the ways that we classify triangles is by the number of congruent sides. Okay, so one of the ways, again, to classify a triangle is by the number of congruent sides. So we have what are called scalene triangles, which have no sides congruent. Okay? So in a scalene triangle, each one of these sides is a different length. Okay? Then we have an isosceles. An isosceles is a triangle with at least two sides congruent. Okay, so remember, at least means it could be all three, but the minimum to be an isosceles is that two sides have to be congruent. And then the third type in relation to the sides is what we call an equilateral triangle. And that is a triangle where all sides are congruent. So this side is congruent to this side, is congruent to that side. So all three sides are congruent. Another way that we classify triangles is by its angles. Okay, so an acute triangle has three acute angles. Okay, so all angles are less than 90 degrees. Okay, so it's an acute. Then we have a right triangle, and a right triangle has exactly one right angle. Okay, remember, right angle is 90 degrees, so exactly one 90-degree angle. So okay, so a right triangle has one right angle and two acute angles. And then we have an obtuse triangle, and that is one with exactly one obtuse angle. Okay, so that would look something like this. So this would be the obtuse angle. So notice that the other two angles must be acute. And then the final one is the equiangular triangle. Meaning all angles are congruent. So this angle is congruent to this angle is congruent to that angle. Okay? All right, then we have our first theorem. Okay? And this is one that you guys all know already. The sum of the measures of the angles of a triangle is 180 degrees. Okay, so using this theorem, if I have this triangle and I know this angle is 80 degrees, this one is x degrees, and this is 3x, then I can find the measure of each angle because I know that the sum of the angles, so measure of angle A plus measure of angle B plus measure of angle C has to equal 180. And angle A is x, angle B is 80, and angle C is 3x. And so now we can solve for x. So we get 4x plus 80 equals 180. Subtract 80. Divide by 4, so x is 25. So now I know that angle A, measure of angle A, has to be 25 degrees. And measure of angle C must be 3 times 25, or 75 degrees. Okay? And those do add up to 180. 25 plus 75 plus 80 equals 180. Okay? So we can use that theorem to find measures of angles if we have all three angles represented. So for instance, another example, if I have this triangle and I know that this angle is x and this angle is 30, then I know that this angle by the box is 90 degrees, so it's a right triangle. So I know that x plus 30 plus 90 must equal 180. So x plus 120 must equal 180. So x must equal 60. And notice that this angle plus this angle have to add up to 90 degrees. Okay. All right. And now our second theorem. Well, actually, let me do some definitions first. Okay. So if I have a triangle and I extend one of the sides, it doesn't matter which side I extend. When I extend that side, I create an angle. Okay. And this angle is outside of the triangle, so it is called an exterior angle. Okay, so an exterior angle is an angle formed when one side of the triangle is extended. And notice it is outside the triangle. Okay. Then the angle adjacent, there's an angle adjacent to the exterior angle that is on the interior of the triangle, and then the other two angles, which would be this one and this one. These two angles are called remote interior angles. Okay, and that's in relation to the exterior angle. Okay, so the remote interior angles are angles inside the triangle that are not adjacent to the exterior angle. Okay, so remote interior are inside the triangle, but not adjacent to the exterior angle. Okay, and so it's always in terms of where the exterior angle is. So if I took the triangle and I decided to extend this side, which would create this angle, we'll call it angle X, then the remote interior angles would be this angle and that angle. Okay, so it's always in terms of where the exterior angle is. Okay, now that brings us to our theorem. The measure of an exterior angle of a triangle equals the sum of the two remote interior angles. Okay? Right, so for example, let's say I have this triangle where this angle is x degrees, this is 120 degrees, and my exterior angle is 4x. So I know that, and I want to find the value of x, so I know that this angle equals the sum of this angle plus this angle. So x plus 120 has to equal 4x. So solve for x. Divide by 3. So 40 equals x. Okay? So, and that means that this angle has a measure of 40 degrees. This one is 120, and this is 4 times 40, or 160. So is 40 plus 120, is that equal to 160 degrees? Are those equal? Yes, they are. Okay. So another example is, let's say I have this triangle, and this is 60 degrees, this is 50 degrees, and this is x degrees. Well, I know that this is my exterior angle. This is a remote interior, this is a remote interior, because they're not adjacent, they're inside the triangle, they're not adjacent to the exterior. So I know x has to equal 60 plus 50, or x equals 110 degrees. Okay? So if I wanted to know this one. So this is x, this is 70, this is 35, and this is y. So I want to find the value of x and y. Well, notice that y is an exterior angle, but y and 35 are adjacent angles, and they are a linear pair, so they are supplementary. So we know then that 35 plus y has to equal 180 degrees. So if I subtract 35, y has to be 145 degrees. Okay, so this is 145. So then 70 plus x has to equal 145. So if I subtract 70, x equals 75 degrees. Okay, so I was able to solve for x and for y. Okay, let's do one more example and we'll be done. So in this example, I know this is parallel to this. I know that this is 50 degrees, this is x, this is y, and this is 45. Okay, well, we know that we have two parallel lines cut by a transversal, and so we know this angle and this angle are alternate interior angles, so they have to be congruent. So x has to equal 45. Then if I look at this triangle, then y is an exterior angle, and so y has to equal 50 plus x, but we know x is 45, so y has to equal wait, I made a mistake. I'm sorry. No, I'm right. Y has to equal 95. Okay? So y has to equal 95 degrees.